Hello. Uh, Good morning, everyone. Good afternoon, everyone. Good evening, everyone. Wherever you are and whenever you are seeing this video. Uh, Welcome you all for this IDP EDP talk series on product thinking and entrepreneurship for electrical and electronic engineers. So today's session is on fascinating journey into electronics and integrated circuits. But before that, I would like to uh, thank the UTHM College Management for providing me this opportunity and inviting me to deliver this lecture series. So I'll be having a couple of lectures over the next coming weeks, and today is my first session where we are going to have a fascinating journey into electronics and integrated circuits. So before we even get into the session, you may be wondering, who am I? So let me give you a very short introduction about myself. So myself, Dr. Arjun Palaniappan, you can shortly call me as Arjun. And my background is electronics engineering. I did my master's in integrated circuit design and then a PhD in electrical and electronic engineering from Nanyang Technological University, Singapore. And my PhD was industry-sponsored PhD, which was funded by NXT Semiconductors, which is one of the world's top semiconductor companies. During my master's and PhD, I was involved in designing various low-power integrated circuits for energy harvesting applications and biomedical implant applications. So after doing my PhD, I got an opportunity to start up my own venture. I got a pre-seed funding of around 250,000 US dollars to start up my own deep technology venture. So I started up a company called Sepsitron in Singapore. That was around 3 years back in 2019. Then I became its CTO, the Chief Technology Officer, where I was involved in designing and developing the hardware for identifying infectious diseases quickly instead of like waiting for a longer time. So after my startup, I then very recently joined iCana, which is part of Foxconn, as a product manager, where I am involved in driving and managing all the new product initiatives and new product development of the company. So all I have around 9 years of industry and academic experience, which is primarily in the hardware development, semiconductors, and integrated circuit design. And the past 3 years, I also had a entrepreneurship experience. So this is just a brief intro about myself. So let's get into today's session, a fascinating journey on a fascinating journey to electronics and integrated circuits. So this entire lecture series that I am going to have is going to be like this. I am going to connect each and every lecture series together so that you will kind of develop that knowledge to convert your IDP EDP project into a real startup venture. So that is my motivation of this entire lecture series. So over the next 5 to 6 lectures, I will be also uh, sharing more information about what a startup is, how can you create a startup, what is a business model, and everything you need to know about building a startup. So today's session is going to be a very preliminary introduction about electronics, integrated circuits, since you are all you are all studying electrical and electronic engineering. So so today's session is going to give you a very high level overview of electronics and integrated circuits. What like we are going to speak many different things. So let's start today's session. So before I start today's session, I want to ask you a question. So I'm having a board here. I'm showing a board here. I want to pause here for around 10 seconds to make you think, what is this? Basically, what is this? what comes to your mind if I show this board and ask you what is this? So let's take around like 10 seconds. Okay, hope you thought about what is this, and maybe many of you may have many different answers. So yes, the most of the people will say that this is a Raspberry Pi board. Most of the people will inform me that if I ask this question, most of the people will say that it is a Raspberry Pi board. Yes, it is a Raspberry Pi board. So my second question to you, what is this? Again, I'm going to give you 10 seconds. Okay, so hope you all thought about this. So again, like most of the people can clearly say that it is a smartphone. It is a Samsung smartphone. Even I have a Samsung smartphone. So yes, it is a Samsung smartphone. In the previous slide we saw a board which is a Raspberry Pi board. But yes, it's a Raspberry Pi board on the smartphone. But most importantly, what I want you to think is both are products. So think in a perspective that both are products, both are electronic products. And why are they called as products, and how do they become products? Yes, it is of course a Raspberry Pi board. It is a Samsung smartphone, but what I am saying you to think is like think in a perspective. See these see the Raspberry Pi board as a product. See the uh, Samsung smartphone as a product. So why it is called as a product, and how it is called as a product? I am going to again pass for 10 seconds here so that you all think why they are called as a product and how they are called as a product. Okay, okay. So why it is called as a product? Because basically this does something. This helps someone to do something. This is needed by someone. So that is why they are existing in the first place itself. Why does a company manufacture this Raspberry Pi board? Why does Samsung company manufacture this smartphone? Because we need it, right? Like we as a consumer need it. And if we don't need it, of course, like the company is not going to produce it, and we are not going to buy it, and the company is not going to make any money if they are going to come up with some product that you don't need it. So that is why they are called as a product. So if you take the Raspberry Pi board, like why do they even why do someone need a Raspberry Pi board? So if you take a Raspberry Pi board, it is primarily catered towards the hobbyists. So if you want to quickly design something, if you want to quickly prototype something, if you want to quickly prototype an electronic system, you need not go to the shop and like get all these microprocessor, all these chips, all these USB ports, and then you need not design your PCB and put all of them together and then start to build your idea or like build your application. Instead, Raspberry Pi clearly found out that it is very difficult to build a build a microprocessor or a microcontroller board like this, that people can readily use it to quickly build applications with it. So that is why Raspberry Pi company came up with this Raspberry Pi board, where they got the processor, where they got all the chips, basically the Wi-Fi, Bluetooth, and chips like that. They got all the communication interfaces, all the communication ports like USB ports, HDMI ports, LAN port, audio jack, and they put together all of them in a very compact size in a small board. so that you can just get this board and you can readily build your application. So so this Raspberry Pi board is even called as a pocket computer. You can even connect your display and you can like make it um, build a laptop with it. You can connect a camera and you can like uh, build a SLR or kind of a digital camera with it. So it becomes very easy if you have this board to build whatever application you want. So you can use this Raspberry Pi board to build many projects like robotics, uh, embedded systems. Like you can use it for like drone applications, like all sort of sensor IoT applications. So all sort of applications you can build it very easily. So that is why it is called as a product, because it is helping you to do something quickly, efficiently, without spending a lot of money, without wasting a lot of time. And again, if you take this Samsung smartphone, what is it doing to you? Because back in the older days, when you see like you will have like very old mobile phones which does not have uh, a lot of processing power. Basically, they can just be used only to communicate with each other. But today's smartphones are basically uh, like a mini laptop. Like you can do many things that a laptop can do with a smartphone. You can take photos, you can do video calls, you can browse the internet, you can do all sort of like gaming, video editing, audio editing. Like it is used for many different purposes. So it kinds of like satisfies many of your needs, like the need for communication, need for entertainment, need for gaming, a need for communicating with others, need for working, because like of course you can read a ebook with your mobile phone. You can read all the Word documents, PDF documents. You can create presentations with your mobile phone. So the mobile phone in today's world is very essential. It has become very essential in everyone's life. So that's why they are called as products. If it does not satisfy any of your needs, then then the company will not produce it first of all, and even if they manufacture it, then no one will buy it, and of course the company will be in loss. So that is why start to see everything you have, everything you see around you as a product. So like your mobile phone is a product, your laptop is a product, your watch is a product, your smartwatch is a product, your TV is a product. So like everything is a product in today's world, and all of these products exist because they are satisfying some of your needs. So this is the very very fundamental thought of any company. So any company wants to create a product that they can sell it and make money. So that is the number one most important point of any startup or any company. So what is needed to build a product? So if I say this Raspberry Pi board is a product, then what is needed to build this? Yes, of course, there are like many things you need to build this. Like you need all these integrated circuits, you need all these passive components like resistors, capacitors, you need all these communication ports, communication protocols like the LAN port, the USB port, the HDMI port, the USB-C port, like all these general purpose input out ports. Then like ports to directly connect your display, ports to directly connect your camera, ports to connect your audio devices. So you need many different things to build a electronic product. So that is what we are going to see today. So let's now jump into a fascinating journey uh, of electronics and integrated circuits. So let's start with integrated circuit. So I'm going to give you a very high level overview of many different things now, so that you can see that big picture of the electronic engineering, electrical engineering, and how things get come and fit together, so that when you are developing a product on your own, you will clearly understand what it takes to build a product and what is needed to build a product. So So yes, we need lot of things to build a product, but first let's start this integrated circuit. So this integrated circuit if is the brain and heart of this electronic product. So if you take any laptop, you can see that the processor they are using is either Intel or AMD. If you take any mobile phone, you can see that the processor they are using is either Qualcomm Snapdragon or MediaTek or like Broadcom, or even Intel AMD processors. So like this processor itself is the heart of any electronic product. Without the processor, like your electronic product, whatever product you are going to do, it is not going to work. But of course, like the processor is not the only component also in the electronic product. You can see many different components, and like everything needs to come together and everything needs to work together in order to um, give you those functionalities that you need. Otherwise, if you just have a processor, like what is the use? Like if you don't have like Wi-Fi, if you don't have any wireless communications, if you don't have any sort of communications, then what is the use of the processor? So the processor is like kind of handling many different tasks that many different integrated circuits do. But let's in general see what a processor is basically. So if you just break open the processor, of course I don't encourage you to like go and like take a Raspberry Pi board and like break it open, but if you like see what is present inside this processor, if you like use a microscope and like if you use a microscope and you see what is inside the processor, you will basically see something like this. So what is this? Like it looks something like alien land, right? It looks something like Mars. Yeah. So this is what is present inside an integrated circuit. Of course, we can't see what is present inside with our bare eyes because things are so small and so tiny inside it. Like we are speaking in the size of like micrometer, millimeter, nanometer, which is like so small that you can't even see it. Like even when you put it under a microscope, you still can't clearly see each and everything inside. Like of course you can just see some patterns like this, some structures like this, but you can't really uh, completely see what is present inside it. So that small is uh, things that are present inside the integrated circuit. So if you just break open an integrated circuit, you will see something like this, and it will basically look like a city basically. So if you take any city, you can see that okay, few areas are reserved for business. A few areas are like business areas where you can see a lot of skyscrapers. Like few areas are like residential areas where you can see a lot of like homes, residential homes. Then maybe few areas are kind of like outside the city. Maybe like it looks like a village, like a lot of like farming and things like that are happening. Few areas like you can see a lot of like trees, like forest, like where you can see a lot of trees and things like that. So this is how basically every city will be, right? So that is how an integrated circuit will also look like. Of course here we are speaking about different types of sub circuits that are present in an integrated circuit. So if you take any integrated circuit, you can see a lot of systems that are present inside this chip. So you can see lot of like logic circuits, lot of memory circuits, lot of like analog circuits and things like that. Um, we will see in this slide that if you see that you can see a lot of like RF circuits, radio frequency circuits, a lot of analog circuits like amplifiers, power management circuits, like clock synthesizers, like transmitters, receivers, transceivers, clock generators, like data converters, analog to digital converters, digital to analog converters, oscillators, mixers. So like memory, logic, arithmetic units, shift registers, like flip flops, multipliers, adders, subtractors. So like there are like billions and billions of transistors present inside a silicon chip, and like each like any system like this will easily have like tens of thousands of transistors connected together to give you the required functionality. So we can kind of like subdivide the integrated circuit design itself into many different fields. So basically like analog IC design, mixed signal IC design, digital IC design, RF IC design, and physical design. So analog IC design deals with all the analog circuits that are present in the chip, like digital IC design deals with all the digital IC design, and things like that for like the RF IC design and the mixed signal design. And finally, physical design is where you uh, kind of like integrate all of the things together to form this silicon chip. So yes, like whatever you have studied in the previous days, like probably you have studied about amplifiers, you have studied about flip flops, registers, clock registers, shift registers, adders, multipliers, subtractors, like half adder, full adder. So you would have studied a lot of things during your maybe like one or two semesters before. So all of these things are now going to be present inside this silicon chip, which is the heart of any electronic product that you can take. So now let's have a look into how we can design this silicon chip. Of course, like uh, many of you will not get into IC design. I understand that, but maybe few people will have an interest to design their own silicon chips. But since this session itself, the aim of this complete session is to give you the high level overview of what a electronic product looks like and how to design an electronic product and like everything associated with it. So that is why like I'm going to give you some information about IC design, and then I'm going to move into other parts of the electronic product itself. So now we are like speaking about IC design. So how can you design a silicon chip? So the very first thing is like if you are designing analog circuit or RF circuit or a mixed signal circuit, you will basically use a tool called as Cadence Virtuoso, where you will design your where you will draw your electronic circuit. You will design the circuit, and then you will simulate it, and like you will uh, uh, test its performance. Like you will simulate it to find out like the specifications, what sort of performance the circuit provides you, whether it matches with the specifications that you have, and things like that. If it is a digital IC design, you will not manually do this circuit design. Basically, you will just use Verilog or VHDL uh, to write your algorithm, to write your code logic, whatever you can say, and then synthesize it. So basically, when you are doing analog circuit, you will manually draw the circuit on your own. You will connect the transistors, you will connect all the passive components, and then you will simulate it. But when you are designing a digital system, basically you will not manually draw it. Like you will write the code and you will like synthesize it, and the software tool will convert your code into a transistor level schematic. So so uh, so uh, what is the purpose of even knowing this? I'm going to give you a very basic example. So if you take a washing machine, you can see that the washing machine has lot of controls, right? So you can like play around with a lot of settings. There are like lot of preset programs that you can choose to clean your clothes. So if you select, if you want something like, okay, I want to heat up I want to heat the water to 40 degrees Celsius. Then I want to like uh, wash my clothes at a certain, then dry it at a certain RPM. If you kind of like uh, create a code like this, there are like many things working together here. So this is what the digital system will basically control. So once you create a program like this, what it will do is like basically it will first turn on the water heater where the sensor will monitor the temperature of the water heater. So once it reaches 40 degrees Celsius, then it will turn off the water heater. Then it will turn on the motor to start washing the clothes. It will turn on the water inlet to then rinse the clothes. It will then get all the detergent and things like that. So once your clothes are washed, then it will turn on the motor to do the drying. Then you will have a sensor which kinds of like tracks the RPM of the motor, and so a lot of these things are happening. So this is where digital circuits and analog circuits closely work together, and this is where whatever you design goes into the end product. So once you do this design, then basically during the physical design, you'll place all these blocks together, and then you will fabricate it. So once you fabricate it, you will basically get your dies that are fabricated in a wafer like this. So each wafer will contain a certain number of dies depending upon the size of your design. So then once you have your wafer, then basically they will dice it, and then they will package it, and finally you will have your integrated circuit. So when you have your integrated circuit, of course you will do some testing, and then like once it is working, then you will build your end product with it. So this is my own journey of building an integrated circuit. I will not go into much details. Basically, yeah, of course, like I designed my own circuit, then fabricate it, and you can see that the size of the chip is like so small. So then after fabricating it, I tested it, and then took a photo of it. So just giving you a very brief introduction here. Okay, so coming back, so we saw this Raspberry Pi board. We saw this board as a product. Then we found out that the IC is one of the most critical component of this product. Then we saw what is present inside this IC. We saw how to design IC and what are all the steps involved in designing the IC. Then of course, like there are like many different ICs. Like of course the workflow of designing an IC looks very similar to what I mentioned before. So there are like various different ICs that are used for different applications. So as an electronic designer, basically you will kind of like get all these ICs and like put them together in your board, and finally you'll create a product. And don't forget that each and every IC is in itself a product, basically. Each and every IC is in itself a product. Even though it goes into another product, it is basically a product in itself. Because if because Raspberry Pi company is the customer that these ICs are catered towards. So of course, like these ICs are catered towards many different customers. So why Raspberry Pi is even getting these ICs? Because it solves their purpose. It solves their purpose of using these ICs to build a small sized computer board. So each and every IC is in itself a product, and these products are now coming into are getting integrated to become a new product that you can use. And of course you can use this Raspberry Pi board in your own project, and you can create a new product, and you can directly commercialize it. So if you maybe you can come up with something like like a small laptop or like a small tablet with this Raspberry Pi board. You can come up with a digital camera with this Raspberry Pi board. So you can do a lot of many things. You can come up with the IoT system. You can come up with a robotic system with this Raspberry Pi board, and that is again a new product that you can uh, sell it to your customer or commercialize it. So a product is kind of a combination of many different products that come together and work together to make the intended functionality. So that is what you need to like clearly understand understand from this slide. Okay, so we saw about integrated circuits. Now let's see how you can build a PCB. Basically, because an integrated circuit in itself like is not going to work. You can't just have that integrated circuit and you can't like just make it work. You need a printed circuit board. You need a circuit basically that uses this integrated circuit to deliver the intended functionality. So that is what a PCB will help you to do. So how do you even design a PCB? So basically a PCB is designed by using active and passive components. So active components mean all the transistors, all the integrated circuits that you have. Passive components mean all the resistors, capacitors, inductors, and those things are called as passive components. So in any PCB, you can see it is a mix of like different active components and passive components to deliver the intended functionality. And of course, you can also subdivide the PCB. You can like section the PCB into different areas and different circuits. So if you see the PCB, there will be few areas allocated for analog circuits, few areas allocated for the digital circuits, and few areas allocated for the RF circuits. So if you see this Raspberry Pi board, you can see that it is getting powered by the USB-C port, and near the USB-C port, you can see a lot of ICs and passive components, and all these are called as power management circuits, because basically different ICs require different supply voltages. So this power management circuit will basically power up the different ICs at an appropriate supply voltage. So even though you input 5 volt into the Raspberry Pi board, like this power management unit will convert that 5 volt into some other voltage level, basically like a 3.3 volt or like 1.8 volt, and then power up all these integrated circuits. Then you can see this Wi-Fi and Bluetooth transceiver chip. You can see this chip and like small antenna that is like printed in the PCB itself. So this is where the RF circuits are there. Then here you can see a lot of like digital circuits. You have this processor, you have memory circuits and things like that. Then you have all the communication ports. Then together with that, you will also see some of the ICs that um, converts the signal that you get from the processor into levels that are suitable for these communication ports and protocols. So it is very similar to an integrated circuit, but it is in a bigger format, and it uses integrated circuits and other passive components to build the PCB. So how do you even design a PCB? So the very first thing you will do is like you will first prototype your circuit. So you'll use your breadboard to connect different ICs together and different components together, or maybe like a dotted PCB board, and then you will like wire all of them together and solder it to test whether your circuit is working fine or not. So once you are sure that your circuit is working fine, then you will draw the schematic of it in a PCB software. Basically, you can use softwares like Altium PCB or like KiCad, 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 Eagle, OrCAD, PSpice. So there are like many different PCB software. So you can use whatever you are comfortable with, and you draw the schematic, and then you lay out the circuit. Then you send it to the fabrication house, which will then fabricate this PCB. So after you fabricate the PCB, then you will assemble all these components together and solder it, and then you will have your PCB ready for putting inside any product. So yeah, again, so my own journey, like after I fabricated the chip, I also had to fabricate my own PCB so that I can do the testing of it, because without any PCB you can't do any testing. So I designed my own schematic, I laid it out, and then sent it to the fabrication house and got it fabricated, and then put my chip here and then started to test it. So this is how basically you will be doing your electronic products. so once you have now you have an understanding of what a silicon chip is and what a PCB is. So now let's sorry for that interruption. So it's my work messages. So once you have the PCB and the silicon chip, then what you can do is now this is where things start to get more exciting and more entertaining. So what you can do is now you can put all of them together and like create lot of systems. So if you take any of these products and if you break open any of these products, you are going to see a PCB. You are going to see a PCB with lot of passive components, with lot of active components, and so that's what we have seen till now, like how to design integrated circuit, how to design a PCB. So once you have done it, then this is where things start to get more interesting, because you are now going to write a program to make it function in a certain way that is going to solve certain problems. So if you take an Apple Watch, of course it is giving you many functionalities. Basically, it is able to track your steps, track how much calories you have burnt when you are doing exercise, track your heart rate. If you take an iPad, it is helping you to do many different things like um, reading ebooks, like many different things, laptop, vacuum cleaner, camera. So if you take any of these electronic product, it is basically helping you to do many different things, and it is all because of all of these components coming together and like uh, coming together and also uh, uh, creating an intelligent algorithm, creating an intelligent software to make it work in a way that it will help you. So this is where things get more interesting. So hardware in itself is not going to be very useful. You always need to have that software component in order to make it more intelligent and meaningful. So as an electronic engineer, it is not that you only learn electrical engineering, electronic engineering. You also need to learn a little bit of software, little bit of software development, how to create your own logic, create your own algorithms, and then you write the program in a way that it will help you to do something. So this is basically what every product does. So of course, once you start to write code and things like that, there are also many things you need to start considering. We have a lot of communication protocols that is helping us in many different ways, helping us to do many different things. So there are like a lot of communication protocols like Wi-Fi, Bluetooth, all sort of like wired communication protocols. You also need to like learn a little bit about how these communication protocols work so that you can use them, use those functionalities as well. So you also need to think when a certain communication protocol can be good, when a certain communication protocol will not be good. So if you take any IoT device, of course you need good communication, wireless communications like connectivity, like Bluetooth or Wi-Fi, Zigbee, LoRa, uh, communications like this. But of course, if it's just a wired communication, you can use HDMI or like USB port and things like that. So you also need to learn a little bit about how to use these communication protocols. Uh, so then you also need to know a little bit about testing and measurement, because without testing and measurement, no product will be successful. I don't know if you all know about the incidents that happened with Samsung Note 10 mobile phone. So it was like around 5 to 6 years back. So Samsung launched the mobile phone called as Note 10. Uh, it was a very popular mobile phone back around like 5 6 years. But what happened was the mobile phone started to like burst. Mobile phone started to like explode because the battery, there was some issue with the battery testing. So like lot of mobile phones started to explode, and it became a serious issue. So then many flights started to ban Samsung Note 10. Many people were like afraid of like buying Samsung mobile phones. After that, the Samsung shares went so down. So a lot of issues happened with Samsung Note 10. So this is where like testing and measurement is very important. So whatever product you do, you can't just like that design develop, and you can't just like that ship it to your customer. You need to do rigorous testing. You need to measure different things, and like you need to like pass certain quality standards. So only after passing certain quality standards you can call it as a product itself. So if you take a Raspberry Pi board, the Raspberry Pi board would have passed many testing and measurement, and would have passed many quality standards also. So basically, because they are using Wi-Fi, Zigbee, all such communication protocols, they also need to pass the FCC standards in order to not violate different spectrums, different communication bandwidths, and things like that. So this is where when you are designing a product, when you are developing a product, you need to have that high level understanding of all these things, like what integrated circuit is, how to design that integrated circuit, what is a PCB, how to design a PCB in an efficient way, how to reduce the size of the PCB, what sort of components you can use so that you can reduce the size of the PCB. Of course, we all need like small mobile phones. We all need like thin, ultra thin, sleek mobile phones. We all need like low weight laptops, low weight mobile phones. So what is the fundamental behind this? Like the PCB is the most biggest bottleneck of these small mobile phones, like low weight mobile phones, because the PCB size directly impacts how big your mobile phone or laptop is going to be, and then the PCB size is going to be directly impacted by the number of components, the how big the IC is going to be. So each one is having a relationship there. If you develop a bigger IC, then you need a bigger PCB, then you need a you can't create a small sleek mobile phone. So the specifications are always like uh, kind of like need to be matched across different domains. So you need to like think of all of these things when you are designing any product. So of course I didn't speak anything about like materials here. So fundamentally, as an electrical engineer or electronic engineer, like fundamentally the integrated circuit is the most important building block of any electronic product. And then we have the PCB, which kinds of combines all the integrated circuits and passive components to help you make your electronic product. But what is fundamentally present inside all of these things? Like inside all of these things, it is the fundamental component is the transistor. So if you take any transistor, that is the most fundamental and important component of this entire electronics industry. Any electronic product, if you have, like, it will easily have millions and millions of transistors. So if you take a smartphone, it will easily have millions of transistors. If you take a laptop, it will easily have like more than like 1 million or million transistor. Any complex processor like the Intel processor, the Snapdragon mobile processor, the MediaTek processor, all of these processors will easily have more than a million, or sometimes can even have billions of transistors. So that small is like, if you take a IC, it is like only like few millimeter cross few millimeter size, but inside it you have like millions and billions of transistor, which means like each transistor is in the size of only few nanometers. So see how complex everything is. So even the transistor even in the transistor, there are basically many different products. Even a transistor is a product, because if you design your integrated circuit with a certain process, that process is a product that the foundry offers you to design. Then you use that product, you use those transistors to design your integrated circuit, which then becomes a product for the PCB, for the system designer. Then the system designer will basically use your product to build a robo or build a drone, or like any sort of a bigger system, and that will become the final product that consumers like you and me will use it. So there are like many innovations happening in the transistor level, which is little bit out of the scope for all of us. because mostly like material scientists help to come up with new transistor structures that consume low power, that occupies low area, that can operate at higher speeds and things like that. So these are some of the transistor structures that are like novel, like FinFET, planar FET, gallium, gate all around, field effect transistor, things like that. So if you see this, why do we even have smaller mobile phones and like smaller laptops? Because fundamentally the transistor size is shrinking. Basically, that is what Moore's law is. So, Gordon Moore, who came up with this statement that every year the transistor size will become half. The number of transistors in an integrated circuit will become double. Will double. So from then on, like we can see that the trend has been like falling transistor sizes, like transistor sizes becoming smaller, and that's why like back in the olden days, like your laptop was like so big, your mobile phone was so big, and like in today's world, you can see like Apple smartwatches, mini laptops, like ultra low weight laptops, ultra small mobile phones, like foldable mobile phones. So these are all possible because of the innovations that are happening in transistors. So, the world of electronics is very big, very huge. So it is a very big cloud, basically. It starts with like transistor. It starts with a basic ultra small transistor that you uh, connect together to make an integrated circuit that you use in your system together with a lot of other integrated circuits and passive components, which then you use it in a bigger system to come up with the final end product that consumers like you and me use. So as an electronic engineer, it is not possible to like develop a deep knowledge in all of these things, but as a product developer, as a product designer, if you want to start up your own company, or if you want to create a product with which you want to, if you want to create a product that you want to commercialize it, then you need to have a little bit of understanding of all of these different parts of the electronics world. So chip design, PCB design, circuit design, testing, embedded systems, coding, algorithm, communication protocols, radio frequency. So you need to like have a little bit of understanding of all of these things so that you can come up with the product that you can commercialize it and you can become a entrepreneur. So that is the entire motivation of this lecture series. And today's session is just giving you that big picture overview of how different things come together and work together to become the product that you use. So as I told before, the world of electronics is very big, and when it is combined together with software, artificial intelligence, and machine learning, the possibilities are endless. The possibilities are infinite, and you can come up with a lot of products that you can commercialize it. Drone applications like autonomous cars, robots, like different types of robotic applications, different types of drones, different types of autonomous vehicles like unmanned aerial vehicles, flights, Internet of Things, industrial Internet of Things. So there are like many different possibilities, many different products that you can build if you are able to develop this understanding of the world of electronics and understanding of software, AI, artificial intelligence, machine learning, and if you have that understanding of how to put both of them together. So with this, I will end my session. Hope you all developed, hope you all understood how different things work together and how different things come together and fit together to become the electronic product that you have in your hand. Hope you all gained that understanding and knowledge. So this is just a introductory session to help you understand, to help you give you a big picture overview. In the upcoming sessions, we will speak a lot about startups, what a business model is, like what do you know, what should you know if you want to convert your IDP EDP project into a startup venture. So if you have any questions, you can always ask me during the next session that we meet, or you can even connect with me in LinkedIn, and you can even ask. So see you all next week, and stay safe. Bye.